Hi everyone. Today we're going to dive into counting principles, permutations, and combinations. So, how do we count the total amount of options when we're dealing with probability? So, we'll start with Manuel's Pizzeria. And so, anyone can pick a size, a crust, and one topping on their pizza. And we have to figure out how many different pizza combinations are available. So, Manuel says there's two different sizes. So there's a medium and there's a large. And then from there, we could choose a deep dish or a thin crust. And from there, we can choose the topping. So if I wanted a medium deep dish pizza with pepperoni, that would be one of my options. So if I wanted to list all the options, I can make a tree diagram and count that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 options. So there's 12 different one topping pizzas. Now, a lot of times I don't care what each option looks like. I just want to know how many there are. And we're going to learn about the fundamental counting principle today that allows us to not make the tree diagram and just count. So let's say we're making a meal now. It's about lunchtime, getting hungry. So I can pick one sandwich, a side, dessert, and a drink. Think of your favorite sandwich restaurant, and this is how they determine how many different meal combinations they have. So what the fundamental counting principle says is that if we figure out how many options there are at each stage, we can multiply those numbers together to get the total amount of combinations. So there are four sandwiches here, there are three sides, there are two desserts, and there are five different drinks. I can multiply 4 times 3 times 2 times 5 and get 100 different meal combinations where I pick one from each category. And that's what the fundamental counting principle states. So, when my wife was looking for a car a few years ago, there was felt like a million options, and we could pick from three different trim lines. So how nice the car was. Do we want it to be a manual or do we want it to be automatic? Bunch of different colors, and do we want cloth or leather seats? So I quickly calculated to figure out how many different possibilities she could pick from, and then she picked the option that she liked best. So there was three different trim lines, and two different types of transmissions, and eight different colors, and two different seat types. So we got 96 total different options. And down here is what she picked. Now, sometimes order matters. So sometimes, like a race, I care who comes in first, second, or third. And then sometimes I just want to make a group of people. I don't care who's first, second, and third in the group. So if the order matters, we're going to use a permutation. So NPR. And this button is on your calculator. You just got to find out where it is. So 5P3 means there's five items, and I want to choose three, and the order is going to matter. So that's 5, 4, 3. Three different spots. Pick three things. I have 5 first, then 4 second, then 3 third. Now, if order doesn't matter, I'm going to use something called a combination, where I'm still going to pick three things, this time out of 10, so 10 times 9 times 8, but I'm going to divide by all the duplicates because I don't care who comes in first, second, or third. So combination problems are when order doesn't matter. So you should also have one of those buttons on your calculator. So we'll run through a few examples of each. Okay, let's say Ava's got 5 songs on a CD. Yeah, I know I'm old. I like CDs. So she wants to arrange her songs in order. Okay, picking one to go first, one to go second, all the way down to last. So that's 5. Pick 5 because order matters. So 5 spots to pick from: 5, 4, 3, 2, 1, which we write as 5 factorial or 5p5. Now, if she only wanted to pick 3 and make a specific order, it would be 5p3, so 5 times 4 times 3. So if order matters, we're going to use a permutation. Now let's talk about Alex and being counselor at summer camp. So he's got to pick three of these activities, three out of these 10 activities. And order doesn't matter. I don't care whether we do archery first or climbing first or which one first, as long as I just got to pick three and the order will come later. So if the order mattered, I can do 10 T3. I can do 10 times 9 times 8. But order doesn't matter here. So if I want to do archery, volleyball, and painting, there's 6 different ways that I can arrange them because I could put 3 of these things first, 2 second, and 1 third. So I have to divide by that 6. So I have to take all the different permutations and divide by the double counts, and I get 10C3. So 10C3 is 120 if order doesn't matter. If order does matter, there's 720. So the major difference between permutations and combinations is, does order matter? If it matters, we use permutations, and if it does not matter, we use combinations.